Hello. All right. Now it's time to talk about conjunctive Boolean retrieval. Basically, a Boolean and, where we've placed a requirement that all of the terms that we specify in our query must be found in a document. And we want to find all the documents in the collection that have all of our queries' terms in them. Of course, they're going to have other words as well, but they must contain at least one occurrence of every word that we give it. If it's missing any of the words we put in our query, we don't want that document. I've always hesitated to actually cover this in an information retrieval course because this is a lousy way to do retrieval. It really, truly is not what we want to do. This is like going back in time to the pre-computer methods. We're going to use a computer to do what we could have done without a computer. This is not what we want to do, but it is very easy to implement, and so it'll give us a chance to test out our inverted indexes to actually make sure that we can use them and they work. And it produces a good straw man. In other words, basically, our other ranking algorithms that we're going to do, which should do a good job of helping find documents that users are likely to find to be relevant, they should produce a much better quality ranking than the set of documents that Boolean retrieval is going to give us. And so we kind of set ourselves up to see what ranking algorithms have so significantly been able to do in comparison to what we had before we had the ranking algorithms. When we were left with the equivalent of Boolean and retrieval in the pre-computer era, we now are able to do so much better. So, do not think that this is what information retrieval is and the course is over, okay? This is like going back in time to establish a baseline at which we can measure how much we have improved since then, all right? And again, it's for illustrative purposes and so forth and so on. It's not an example of what to do. It's an example of what we don't want to do. All right. Now with that in mind, let's go ahead and get on to it. And let's explain this to people to be sure you actually understand how it works. So we'll start with an example here. I believe this example, I got it from Charlie Clark. Charlie, I don't know, maybe it was in a course he taught or examples he's given in person, talking about you wanting to find documents about shark attacks. And so with a Boolean and query, you're going to type in shark and attacks. Now, of course, if our search engine can only do Boolean and retrievals, we wouldn't have to require a user to type that. But that's the idea is we want to find this word and this word in the documents. All right. Now, Boolean and retrieval, one thing to note is that it returns a set. It does not return a ranking, so to speak. So basically, it identifies a set of documents and gives them back. And they all, from the Boolean retrieval perspective, are equally, it thinks they're all equally likely to be relevant to the user. It's like, here are the documents, here they all are. It's one gigantic set. It's like a ranking in that it's picked those over all the other documents in the collection, but the documents it returns have no ordering preference to them at all. And that's very different than what we do with modern ranking algorithms. So it returns a set of all documents in the collection such that a document has a count greater than or equal to 1 for the word shark and account for tax that's also greater than or equal to 1. Remember that account of a word in a document is called its term frequency, or TF. All right. So let's take a look at how this would work. We would have a posting list for the shark postings. And we would have a list of postings for the attacks. So we're going to end up with an array here. And shark is found in document 5 once, document 8 twice, document 23 is found once, document 56 found 6 times. Then in attacks, tax occurs much more than the word shark. And document 1 3 times, document 4 2 times, document 8 1 times, document 9 4 times, document 50 3 times, document 56 4 times, and document 101 3 times. I'm going to be referring to this example later on, so that's why I'm bothering to put it up on the board. But again, look, let's think about how we can do this retrieval. We want to find all the documents that contain both of these words. And so what's interesting is our inverted index, when we fetch the postings for shark and we fetch the postings for attacks, these are all the documents that contain these words. And so we want to find the documents that are in both of these lists. That will be all the documents we care about. If you're not in both of these lists, we don't want you. All right. So document 1 and document 3, well, wait a minute. Document 1's no good. Document 4's no good. Document 8, well, document 5's no good. Oh, document 8. So we've got document 8 matches. Then we can advance both of these. 9, 50, 56, 50, oh, 56 as well. And then we're done. So only documents 8 and 56 are found in both of these postings lists. And so the only 2 documents that would be returned from this example are documents 8 and 56. Again, we're ignoring the counts. We're only concerned, are they greater than or equal to 1, which that's what our postings tell us. They tell us these documents are the documents that have 1 or more counts of these words in them. We will be paying, of course, attention to term frequency when we get to our other ranking algorithms, which is why we bothered to store it in the inverted index. If the only thing we wanted to do with our inverted index was Boolean and retrievals, we wouldn't have bothered to store the term counts, because we just would have recorded that these are the documents in which these words occur at least once in. All right. How could we go about doing our Boolean retrieval? Well, let's look at a naive approach. It works. It's easy to implement. It might very well be what you want to implement on the homework. Because, by the way, naive is still plenty fast for the homework. And if it's easy to implement, that makes your life easier, and there's a good chance you'll get it right then. So naive approach is we're going to count the number of times each document, or spelling of each is horrible, each document occurs And then if the count is equal to number of words in the query, then it contains all words. The algorithm I sort of showed by hand was doing an intersection of two lists. That actually is a more sophisticated algorithm. By the way, that's an intersection of two lists, and thus we actually are going to end up wanting to do intersections of people's queries are going to range from 1 to n number of terms, so we would have to write an algorithm that can handle an intersection of many lists. We'll show you that later. First, this naive approach, which is easy to code. So I'm going to go ahead and give myself some more space on my whiteboard here. So this algorithm, so we're going to let our document count be a dictionary that maps from integer to integer. Okay, so remember our documents are represented by IDs. So we're going to go from a document to the number of times we've seen that document in all of the postings. So we're going to go through each term in the query. Now keep in mind our query, these are token IDs. Okay, so this is after you've taken your query, you run it through the tokenization, you then look up those tokens in the lexicon, and you get back a set of term IDs. That's what the query is, all right? So for each term t, so these will be integers, we're gonna go and have this nice loop. We're gonna fetch the postings from our inverted index. Now this is what you have loaded back up into memory at the start of running this code. So you've read this in from disk and you've put it into your very nice dictionary that maps from term ID to postings. So it lets us easily fetch it. We know that term will be in the inverted index because when we convert the query to token IDs, our lexicon will only give us back IDs for words that we have seen in the collection, which are all the words that we have in our inverted index. Again, if a word is in a query that is not in the lexicon, we just throw it out. It's gone. We just ignore it. Now you might say that for Boolean and retrieval, we should just give the user 0 results. Again, I think we're going to apply throughout the entire course this nature, which is if a word doesn't appear in our collection, in our vocabulary, we're just going to ignore it from the query. We're not going to default to give no results for a user. All right, we're going to actually process what remains of the query. For each doc ID in the postings, if the doc ID exists in our document count, then this is like counting words, by the way. You know, so it's the same idiom or pattern. Ooh, I could write a whole book on patterns. Ha ha ha. No. Anyways, so we're just going to increment the count if it's already there. Otherwise, we set its count to 1. All right. Then we end that loop over the terms. All right. And then basically we're going to create this result set. So again, we're producing a set of documents that we're going to give the document, give to the user. I'm not going to give the document, give to the user. So we're going to let the result list be an empty list. And now we're going to go through all of the doc IDs in our dictionary of doc count. So these are all the documents that have, this is the union of all the documents that contained any of the query terms. And so then we ask, well, if the doc count of doc ID is equal to the number of words in the query, then we're going to add that document to the result set. And then we'll be done after we go through that loop, and we can just return the result set as the result of our Boolean retrieval. Okay, so that's not that bad. We're just going through all these postings. We're counting every single time we see a document. It means it existed in that posting list. It'll only be in a posting list once. So if it shows up the same number of times as the number of words in a query, we know that we had all of the words in that document from the query. Success. Easy to code. Not the best efficiency, but it's not horrible. How does it work? So the example that we had with the postings on the previous whiteboard, pretty simple. That's pretty easy. Is, you're basically going to produce for our document count. We're going to see that we get document 5 goes to a count of 1. Document 8 goes to a count of 2. Document 23 goes to a count of 1. Document 56 goes to a count of 2. 1 goes to 1. 4 goes to 1. 9 goes to 1. 50 goes to 1. And 101 goes to 1. And so then when we loop through these and we go, hey, our query had 2 query terms in it, only doc 8 and doc 56 have a count of 2. So those are the documents for which the result set would contain, which is what we said before. All right. Next, I'll continue with another video which looks at a non-naive approach to doing the Boolean retrievals. Okay.